Hey everyone, Miss Larson here with a video about significant figures. They're also known as Sig Figs, and you might have heard of them before, but you might not have. They don't use them in math class, but we do need to use them in chemistry. So, what are they and why do we use them? Well, a significant figure or a significant digit or a sig fig is basically all the digits or numbers that can be known with certainty in a measurement plus an estimated last digit. So what that means is down here with this ruler. So see how we have each centimeter marked off, like 8 centimeters, 9 centimeters? But I could estimate one more digit, if you will. So if the arrow is right here, I could say, oh, that's at about 8.5 instead of saying either just 8 or 9. I could say 8.5. So that's the estimated last digit that we're talking about there with significant figures. So these significant figures provide us a way to keep track of the limits of the original measurements that we took when we're doing chemistry. So if we're measuring something, if we're trying to find density or volume or mass, and we're going to use some sort of a device to measure it, like a balance or a ruler or a graduated cylinder, we can take measurements with whatever the numbers are plus one estimated digit. So like here would be like 8.5. Here might be like 9.1, but we can estimate that last digit. And we always are going to continue using significant figures, even if we do problems involving data that we've taken, because we want to keep track of the limits of what our original measurement was. So in determining the number of significant figures in a number that you might be given in a set of data, you're going to have to know 3 rules. And this is the first one. All digits are significant. So any number 1 through 9, so 1, 2, 3, 4, 5, 6, 7, 8, 9, is automatically considered significant. So 45 kilograms as a measurement is going to have 2 significant figures or 2 sig figs, because that's 4 and 5. 4 and 5 are both numbers that are 1 through 9. They're both digits. Next rule regarding zeros. Any zero that is between significant figures, between 2 other significant figures, 2 digits 1 through 9, is going to be significant. So any zero that is between 2 numbers that come between 1 and 9 is significant. So here, this 3 is significant because it's a digit 1 through 9. This 0 is significant because it comes between 2 3s, which are digits between 1 and 9. So significant, significant, significant. That means a total of 3 sig figs there. And then in this example, we have 9009, 9009. Well, we know the 9 is significant. We know this 9 is significant because of rule number 1. But we have to think about these zeros. The fact that these zeros are in between 2 other significant digits means that they are significant. So 9009 makes 4 sig figs for that measurement. The last rule is sometimes the trickiest, and this is that any zero that comes after a digit and, not or, but and a decimal is significant. So any zero that comes both after a digit and a decimal, not just after a digit, not just after a decimal, but it's got to be after a digit and a decimal is significant. So 93.0 grams. This is significant. This is significant. Here's our decimal. This 0 comes after some digits and after a decimal. So that is significant, meaning we have significant, significant, significant. That is 3 sig figs. Next up, 4.00. 4 is significant because it is rule number 1, a number between 1 and 9. Here's a decimal, and then here's a 0, 0. Both of these zeros are significant because they both come after a digit and after a decimal. So that means significant, significant, significant. That's 3 sig figs. Ooh, this one's a little different. We have 0.0090 centimeters. And this gets to be a little bit tricky because we have a lot of different zeros and actually not all of them are significant. So We want zeros that come after a digit and after a decimal. So this 0, is that after a digit and a decimal? No. This 0, is it after a digit? No. Is it after a decimal? Yes, but it's not after a digit, so not significant. This 0, is it after both a digit and a decimal? No. 9, that's a digit, that's significant. And then this 0, is it after a digit? Yes. Is it after a decimal? Yes. 2 sig figs here. All right, let's look at this next example, 700 kilometers. Okay, 700. All right, the 7 is significant. It's a digit 1 through 9. But those zeros actually are not significant because they do not come after a decimal. They are after a digit, but they are not after a decimal. So there we actually only have one sig fig, and that is the 7. Finally, I have 200.0 kilograms. And how many sig figs do I have? Well, I have 200.0. Now, this one is actually kind of an interesting example because this gets into kind of a tricky rule where if you have a decimal, any numbers that come after the digit are significant. So 200.0, it actually has 4 sig figs because the 2 is significant, and then all of the zeros are significant because there is a decimal and they come after the digit. So that's a total of 4 sig figs. So when you're doing your sig fig rules, just remember all digits are significant. Any 0 that is between significant figures is significant, and any 0 that comes after a digit and a decimal is significant. And going back to that last example, 200.0 kilograms, almost think of the decimal place as being kind of like a digit, if you will. Think of it as kind of being a significant figure there, the fact that it's a decimal. So these kind of come between two important things, the 2 and the decimal place. So anyway, that last one, 200.0, has 4 sig figs because those zeros come after the digit and there is a decimal involved. Thanks for listening and practicing with sig fig rules. Remember, all digits are significant. Any 0 that is between 2 significant figures is significant, and any 0 that comes after a digit and a decimal is significant.